Problem 4. Evaluate the integral of 1 over 2x plus 1 dx from 0 to 3. All right, I do notice that there's something in the denominator, and so I know that my goal is going to be to make it say du over u, because if I do that, then I know the answer will be the natural log of u. So that's where I'm headed on this one. So we're going to let u be the denominator, which is 2x plus 1. The derivative of 2x plus 1 would be 2 dx. I notice that I don't have a 2, I just have a 1, so we want a 2 there, which means to compensate for it, I need to put a 1/2 out front. So I'm going to have 1/2. 2 dx both become du, and 2x plus 1 becomes u, so I am all set and good to go. I know that the integral of du over u is just natural log, so this is going to be 1/2 natural log of the absolute value of u. Okay, a couple different approaches that I can take on this one. I'll take both approaches, so you can pick which one you like better. If I decide to change 3 and 0 into u values, if I plug 3 into this u value right here, 2 times 3 plus 1 is 7. And if I plug 0 in, 2 times 0 plus 1 is 1. So at this step right here, I can go ahead and evaluate it at 7 and 1. So I'll have 1/2 natural log of 7 minus 1/2 natural log of 1. We know that the natural log of 1 is equal to 0. So my answer would be 1/2 natural log 7. If I wanted to go a step farther, this 1/2 power could be brought up here, and I could turn this into the natural log of the square root of 7. Either one of those answers is 100% appropriate and correct. All right, if I did not take that route, I would have subbed my u back in, which would have been 2x plus 1. And then I would have just evaluated at the normal endpoints that they gave me in the problem. So I would have had 1/2 natural log, plug 3 in, 2 times 3 plus 1 is 7, absolute value of 7 is 7, and then minus 1/2 natural log. If I plug 0 in, 2 times 0 plus 1 is 1, the absolute value of 1 is 1, and notice I'm in the exact same spot that I was in the other side of the problem. So either way is totally fine. Problem 5, evaluate the integral of secant 5x. Okay, there's no denominator in this one, so I do not want to make it say du over u. Okay, I do have a formula for secant. I know that the formula of secant u du is equal to the natural log of secant u plus tangent u plus c. So that's where I would like to head on this problem. So I know that I'm going to let my u be the 5x. So u is 5x. The derivative of 5x is 5 dx. I do not have the 5 in my problem, so I'm going to put the 5 in the problem, which means to undo it, I need to put a 1/5 on the outside. So I'm going to have 1/5. I did absolutely nothing with secant. The 5x turned into u, and then the 5 and the dx turned into du. So now notice my problem is set up exactly how I want it to, so my answer is just going to be 1/5 the natural log secant u plus tangent u plus c. All right, this next one, it does say to evaluate the integral again, 4x minus 6 over x squared minus 3x plus 5. I do see a denominator, which usually means I would like to get du over u so that I can use the natural log of u. So if I want du over u, I'm going to let u be my denominator once again. The derivative of x squared minus 3x plus 5 is 2x minus 3 dx. And I do notice that I have 4x minus 6. This is too big. I needed to say 2x minus 3. So I do notice that if I multiplied this by 1/2, it would say 2x minus 3. So if I'm going to multiply by 1/2 on the inside, I need to multiply by 2 on the outside. So on the inside now, the 1/2 4x minus 6 dx turns into du. The denominator is u. So now I have it exactly where I want it. The integral of du over u is just natural log of u, which is x squared minus 3x plus 5, and then plus c.